Okay, we're going to be going over the review for the final exam here. So this is comprehensive. All this stuff goes from the beginning till the very end. So you may have seen similar questions to these on previous reviews we've done. So if you want to study even more, you can go through previous reviews and go over those questions as well. Those will help. But let's just get started. So the first question says to solve the equation for t. So to solve for the equation for t, we need to get t by itself. So to do that, we need to get rid of anything next to t. So next to t, I have negative 4 over 3 times t equals minus 12. So the opposite of minus 4 over 3 times t is you either divide by that or you multiply by the reciprocal, like we discussed in class. So whenever you have a fraction, you can undo it by multiplying by the reciprocal. So the reciprocal of minus 4 over 3 is going to be minus 3 over 4. So we're going to do minus 3 over 4 times the minus 4 over 3t equals to the minus 12. And we're going to multiply by minus 3 over 4 here. So what I did here is all I did was I multiplied both sides by minus 4 over 3, by minus 3 over 4. So we said the reciprocal of this was minus 3 over 4, so I'm going to multiply both sides by that reciprocal. So minus 3 over 4 times this side, minus 3 over 4 times this side. Okay, so we're going to multiply both sides by that. Here, I'll zoom in a bit. Okay, and then after you do this, you're just going to be left with t on this side, because multiplying by the reciprocal gives you just 1. And then on this side we have minus 12 times minus 3 over 4. So you can think of it as you can think of it as minus 12 over 1 if it'll help you visualize it, times minus 3 over 4. So that's the same thing as this. So minus 12 over 1 times minus 3 over 4. Okay, just think of when you multiply fractions, you multiply it straight across. So the numerators get multiplied and the denominators get multiplied. So minus 12 times minus 3, that's going to give you positive 36. And then the bottom is 1 times 4, which is just 4. And you can simplify 36 over 4 to just be 9. So your answer would just be 9. 9 times 4 is 36. Okay, so number 2. Solve the inequality and then graph the solution on a number line. Okay, so to solve an inequality, you treat it just like an equation, and then just the inequality sign is similar to an equal sign if you're just solving it. So to solve this, we need to get x by itself. So to get x by itself, we need to get rid of anything next to it. So we see 2 plus 3x is less than 20. Okay, so remember, think of like reverse PEMDAS if you want to figure out the order of things to get rid of. So this addition should be you should get rid of this first and then get rid of the multiplication. So to get rid of the addition of 2, we have to subtract by 2 to both sides. So we start with 2 plus 3x is less than 20. Okay, so on both sides we're going to do minus 2 on this side. We're going to do minus 2 on this side. Okay, so if you take away 2 from here, you're going to have just 3x. And on the right side, we're going to have 20 minus 2, which is just 18. Okay, so we have 3x is less than 18. Now to continue from here, we need to get rid of the 3 times x. So to get rid of the multiplication of 3, you have to divide by 3. So we're going to divide 3 from 3x, which will just leave you with x. So 3x divided by 3 is x. And then 18 divided by 3, that's going to be 6. Okay, so this is the inequality solved. And now you need to make a number line. So, guess I can try to draw it here on the screen. Let me see. Okay, so let's say you have a number line here. So it's not going to be perfect. Let me just keep picking it, I think. Yeah, okay, so a number line has 2 arrows on it. Then you also have, if you're drawing a number line, you just need the middle line most importantly. So we'll just say where 6 is right here. Okay, so when x is less than 6, it's not less than or equal to, it's just less than, right? So you're going to draw a empty circle where the 6 is because it's not equal to 6. And then from here, all you do is use an arrow. So let me flip it. Sorry, this isn't the best quality, but hopefully this gets the message across. So you have an empty circle at 6, and then you have a left arrow going to the negative infinity direction. So if you wanted to graph this on a number line, it would look similar to this. So the left arrow, because it's less than it, and then empty circle. If it was less than or equal to, this would be a shaded circle. Okay, but that'd be your final answer. Okay, this one says graph the equation, must write and use at least 3 coordinates, and then the equation they give you is y equals 2x plus 2. Okay, so when you want to graph an equation, you need to just get 3 coordinates from the equation itself. So the best way to do that is to plug in stuff into the equation itself. So what I mean is we're going to make a table. So we're going to have a table for x and y coordinates. So let's just make one real quick. Yeah, so we just need 3. So this will be our x, this will be our y. Okay, so we'll just pick 3 values for x. So let's pick 0, 1, and 2. Okay, so we're going to plug in 0, 1, and 2 for where x is in the equation. So we're going to have y equals 2 times x, which is going to be 0 for our first number, plus 2. So 2 times 0 is 0, so we have 0 plus 2, and 0 plus 2 is just 2, right? So our first value is going to be 2 for y and 0 for x. So next line, we're going to do the value of 1 for x. So we're going to have y equals 2 times x, which is going to be 1 now, plus 2. Okay, so 2 times 1 is just 2, plus 2 equals 4. So now our y value is 4 for this coordinate. And then thirdly, we're going to have y equals 2 times x, which is now 2, plus 2 equals, so we're going to have 2 times 2, which is 4, plus 2. This is going to equal 6. So we have our 3 coordinates now. We have 0, 2, we have 1, 4, and 2, 6. Okay? And I already have it pre-graphed out on a different screen. So this is what the graph would look like. So 0, 2, 1, 4, 2, 6. Yeah, you can see it on the graph. So, and all they did was draw a line between them. Okay. All right, next question. Okay, so this one says to find the slope of the line containing these pair of points. So if you remember, we need to have the slope formula memorized so you know how to find the slope. So remember, slope is y2 minus y1 divided by x2 minus x1. So remember, memorize this formula if you don't already have it memorized. You're going to need this in the future and other math classes especially. So this is the basics. So slope formula is this. So we're going to use this formula to get the slope of the line through these 2 points. So a line that includes these 2 points on it. Okay, so we need to just take y2 and y1 and x2 and x1 from these points and plug it into the formula. So to do that, we just assign one of these to be x1 and x2, or x1, y1, x2, y2. So let's just make this one x1, y1, and then this one can be x2, y2. So it doesn't matter which ones you decide to make x1, y1, but just be consistent and make the other one x2, y2. Okay, so we're going to take y2, which is going to be 7, minus y1, which was going to be 5. Then we're going to divide, and then it's going to be x2, which is 2, minus x1, which is 0. Okay, so this is going to come out to 7 minus 5 on top, which is 2. On the bottom, we're going to have 2 minus 1, which is 1. So 2 over 1, that's just going to be 2. And that's it. So your slope is 2. All right. This one says to simplify, do not use negative exponents in the answer. So remember on negative exponents, if you have a negative exponent, to get rid of the negative exponent, you just move it to the bottom or the top of the fraction bar, and then just you can get rid of the negative sign that way. So in this case, this is t to the negative third times t. Okay, so remember t, or let me make it lowercase, t to the minus 3 times t. Okay, another way to visualize this is that the t right here is t to the first power, because if it doesn't have an exponent on it, you can just assume it's 1. So remember, when you're multiplying exponents with the same base, all you have to do is add the exponents together. So if you just straight up add these right now, minus 3 plus 1 is going to be minus 2, right? So this, if you multiply these together, you're going to get t to the minus second power, right? So we have t to the minus 2, but it says to not use negative exponents in our answer, right? So we have to change this to not be negative. So the way to do that is to move this to the bottom of the fraction bar. So we're going to put it under a 1. So it's going to be 1 divided by t to the minus 2. Okay? So this right here, this right here would be your final answer. Oh, I mean, sorry, forgot to get rid of the minus sign. So yeah, when you move it to the bottom, it becomes positive, right? So there shouldn't be a negative there. My mistake. But yeah, so this would be your final answer. 1 over t to the second power, positive. So this works in reverse as well. So say that your t to the minus 2 was on the bottom. So say you started off with t to the minus 2 on the bottom. If you wanted to make this positive, you have to move this to the top. So you have to move it to this side of the, or the top of the fraction bar, right? So if you wanted to make this positive, you just move it to the top and then make it positive. So you just have t to the second over 1, which is just t to the second. Okay, but that's not related to the problem. That's just an example just to show you it works both ways. Okay? So this is the answer to the problem. Okay, so let's continue. So subtract. So this is 8x to the fifth plus 3x to the fourth plus x minus 1 minus blah, blah, blah. So we have two polynomials and we're subtracting one of them. So the most important thing here is that we remember, here I'll just rewrite the problem. So 8x to the fifth plus 3x to the fourth plus x minus 1. Okay, so most important thing is when you see a minus sign outside parentheses like this, is that you remember to distribute that minus sign to everything inside the parentheses. So the 8x to the fifth is going to get multiplied by minus 1. This is going to be multiplied by minus 1. And then the minus 1 is going to be multiplied by minus 1. So everything is going to get that minus sign. Okay? So if we distribute the minus sign to everything, we're going to get minus 8x to the fifth. We're going to get minus 3x to the fourth. And we're going to get positive 1, because minus times a minus is plus. So if we just distribute that minus sign to everything, this is what comes out of it. Okay? So now we need to just combine like terms from here on out. So let's combine like terms. Okay, so is there anything that's to the fifth power of x? Well, yeah, there is. So 8x to the fifth and minus 8x to the fifth can combine. That actually makes 0, so we don't have to write it. Now we have 3x to the fourth. Here, I'll write it actually just for visual purposes. Okay, so 3x to the fourth. Is there another x to the fourth? Okay, there is. There's a minus 3x to the fourth right here. So this is also going to cancel out completely and give you 0. So 3 minus 3 is 0. 8 minus 8 was 0. So that's why they're canceling out. Here we have x. Is there another x? Nope. So we have x. And then we have a minus 1. So minus 1 plus 1, that's also 0, right? So our final answer is actually just x from this whole problem. Okay? Number 7 says multiply. So remember, if you have two binomials next to each other like this, you can use the FOIL method to multiply them out. So remember, FOIL is first, outside, inside, last. So that just tells you the order in which to multiply these to get the answer. So remember, so the first refers to the first term in each parentheses. So x is the first here, and then the x is the first here. So we're going to do x times, x times x. So the asterisk means multiplication. So x times x, and then we're going to do plus. So now outside, So outside refers to the most outer terms. So x is the outer one here, and minus 6 is the outer one here. So x times minus 6. Now we're going to do inside. So the inside term here is 6. The inside term here is the x, because they're the most inner ones. So it's inside, so 6 times x. And then we do last. So last is the last term in each parentheses. So 6 here, and the minus 6 here. Those are the last two terms. So 6 times minus 6. Okay. So now from here, all you're doing is simplifying the terms. So x times x, that's going to be x squared because they're both, it's like x1 times x1, which will give you x2. Now next one is x times minus 6, that's just minus 6x. Then we have 6 times x, that's just plus 6x. And then we have 6 times minus 6. So 6 times minus 6 is going to be minus 36. Okay, we're not done here. There's still terms we can combine. So the minus 6x and the plus 6x can both combine. So we need to do that. So minus 6x plus 6x actually just gives you 0. So you don't have to write 0. So now you just have x squared minus 36 left over. Now this is your final answer. You can't simplify that any further. So that should be your final answer. Okay, 8. Evaluate the polynomial for x equals 1 and y equals 2. And then it gives us x squared minus 2y squared plus 3xy. Okay, so when it says to evaluate a polynomial and it gives you the values, all you really have to do is take the x and y value and plug it into the expression they give you. So wherever x is, we're going to put 1, and wherever y is, we're going to put 2. So 1 squared minus 2y squared, so there's going to be 2 squared. So it's 2y squared plus 3xy. So 3, 1, 2. Okay, so all I did was substitute in x and y into the formula, or the expression. Now we just have to simplify this. So 1 squared, that's 1 times 1 is 1, so it's still 1. And then here we have 2 times 2 squared, so we have to do PEMDAS, so order of operations. So exponents comes first, so we're going to do 2 squared. So 2 squared is 4, so we're going to have 2 times 4. And then we're going to have 3 times 1 times 2, so 3 times 1 is 3. And then 3 times 2 is 6, so we're going to have 6 here. So I'll simplify what's left over, so 2 times 4 is 8. So we have 1 minus 8 plus 6. So 1 minus 8 is minus 7. Minus 7 plus 6 is minus 1. So final answer is minus 1. And that's it. So minus 1 is your final answer. Okay, so number 9. Okay, so this just says to factor. So x third plus 6x squared. So when it says to just factor, you have to think of what common factors you can take out of the expression. So is there a common factor between x third and 6x squared? Well, yeah, there is, right? Now, they don't have a number in common. This has a 1, x to the third, and this is just 6x squared, so there's no number in common. But they have a variable in common, which is x squared. Yeah, sorry about that. So the common factor here is x squared. So there's going to be, so if you take out x squared from x third, so x third divided by x squared is just x. And then 6x squared divided by x squared is just going to be 6. So if you take the common factor out of both of these terms, this is what you're left over with inside the parentheses. And that's your final answer. So this cannot be simplified any further. So you have x squared times x plus 6. Number 10 says to factor by grouping. Okay, well, we've seen a problem like this before in the other review I gave for test 3. So when you see factor by grouping, if it's shown like this, you can already see that we have two terms. So you have n times n minus 6, and then 3 times n minus 6. So you need to think of a common factor that can be taken out of both of these. Now in a problem like this, it's really obvious. So what's common to both these terms? Well, n minus 6 is, right? Both these terms have n minus 6, so we're going to write n minus 6 as a common factor. And then what's left over when you take n minus 6 away? You have n here, and you have plus 3 here. And that's it. So those are your common factors, and that's the end of the problem. So that's your answer. So n minus 6 is one factor, and then what was left over was the other factor, if that makes sense. So n plus 3 was all that you had left over, so that's why we wrote it right here. Okay, but that's it for the review, so good luck.